today's lesson, we'll be talking about differential leveling, which is lesson 3.2 of the fundamentals of surveying. So for the learning outcomes, we have three learning outcomes for this lesson, which is first is to explain what is differential leveling, then explain the purpose of conducting differential leveling and sample computation of differential leveling data. So short recap for the previous lesson on what is leveling. So imagine this is a mountain and you're standing at the low elevation of the mountain or sa mga flat terrain. Then from your position, you can see a tourist spot on the top of the mountain. With that, na-curious ka on how high is the mountain, how high is the tourist spot, this one, or what is the difference in elevation from your position to the tourist spot. So, out of your curiosity, mag-conduct ka of surveying. With that, leveling ang tawag on the process of measuring or determining the difference of elevation between 2 points, which is from your position to the tourist spot or on, above, or below the ground. Then for the objectives on when to conduct a leveling, the first is to find the elevation of a given point with respect to the given or assumed datum. And the second is to establish a point at a given elevation with respect to the given or assumed elevation. Then for the equipment that we'll be using in conducting leveling is first is the level instrument, or usually we use an automatic level. Then second is the graduated stock or rods. This is a stock or rod where measurements either a metric or English system. And lastly, the tripod where we establish our level instrument at ibutang ang ating level instrument on top of the level head. Then, by definition, differential leveling or leveling itself is the process of determining the difference in elevation between two or more points. For this case, assuming that BM1 is known elevation, then you want to determine the elevation of BM2. And differential leveling requires series of setups of the instrument along the general route for each setup. So, series of setup. So, set up instrument here, first setup of instrument, and second setup. So, why do we conduct series of setups na? Because in reality, assuming this is a mountain, then nag-set up ka og instrument between sa imuhang BM1, which is the assuming known elevation, then ang imong BM2, which is your desired or to be determined na elevation. But pag set up nimo instrument, nag-anak ka, nagbutang ka og rod sa imong station, then pag sight nimo, because of the drastic change sa iyaha slope, ang imong makita is the terrain instead of graduated rod. Although sa imong backside ay imong foresight, when i-sight nimo imong benchmark 2, makita nimo imong rod, but sa imong backside, when we sight BM1, ang imong makita is the terrain. With this, ang atong buhaton ay portion. So, we set up here the instrument where we can sight the benchmark 1, then mag-create ka og in-betweens nga station. Then, set up na po ka sa second instrument para makita ang atong benchmark 1. So, definition. First is the benchmark is a fixed point of the reference whose elevation is known or assumed. So, this is benchmark. Second is the backside is a reading taken on the rod held on a point of known or assumed elevation. For backside, assuming na this is your direction of leveling. Ang imong readings na opposite sa imong direction of leveling is called backside. For this case, from here to here, mo nang atohang backside. For our backside reading is from the ground to the line, to your line of sight. From the ground to the line of sight. And also, backside is frequently referred or called as plus side. The next is the foresight. It's a rod reading taken on a rod or point whose elevation is to be determined. So, ang foresight naman along sa imong direction of leveling. So, imong foresight reading is from the ground to your line of sight na along sa direction sa leveling. And it is often referred as minus sight. Turning point is a intervening point between two benchmarks upon which point of two benchmark. So this is your benchmark 1, benchmark 2. Any station kung asa ninyo i-position ng inyong rod is called turning point. And it is called change point. It is also called change point. And lastly is the height of instrument. Height or height of collimation is the elevation of line of sight of instrument above or below a selected reference point. So, ang height of instrument is the elevation of your line of sight from the mean sea level, which is commonly used as reference datum in surveying, mean sea level to your line of sight. So, kung ang backside and foresight from your ground or terrain to your line of sight, the height of instrument is from the datum to your line of sight. Okay. So, the formula that we'll be using in computing differential leveling. First is HI is equals to elevation of DMA plus backside. So, to determine the elevation of your line of sight, so ang benchmark nimo, which is a known elevation, kaning from mean sea level to your ground, known siya ang iyang elevation, plus backside, mo ni atong height of instrument or HI. Then, para makuha na po nato ang turning point, ang atong height on the ground, sa atong turning elevation, sa atong turning point, we have height of instrument minus foresight. So, natay height of instrument minus sa atong foresight readings. So, mo na atong turning point. Then, para na po makuha ang atong height of instrument on the second setup na natay elevation sa turning point, mag-plus na po sa atong backside reading para makuha ang height of instrument on the second setup. Then, lastly, to determine the elevation of your benchmark 2, which is unknown elevation, na makompute nato ang HI, compute na nato, minus sa atong foresight reading, which will be the benchmark 2. Nato elevation of our benchmark 2. So, sample sa atong leveling notes. Sa atong leveling notes, when we conduct it in the field, natay 5 columns. First is the station, then backside, which is BS, height of instrument or elevation sa atong line of sight, then foresight, and lastly is the elevation. So, ang atong ibutang ang atong mga station, which is the benchmark A or the known elevation, then atong mga turning points, then lastly is the atong unknown elevation or unsa atong point na gusto nato i-determine ang elevation. Then, to compute that, kay known man ang atong BM1, kani siya elevation of BM1, known ni siya, butangan plasan nato sa atong backside para makuha ang atong HI. Then, para makuha ang elevation sa turning point 2, natay computed na atong HI minus sa atong foresight. Then, mo na ang atong elevation sa turning point 2. The same ra pag-compute sa HI sa turning point 1, then HI for height of instrument for second setup, niya mo na po ang atong gamiton nga formula to compute the elevation of our mga turning points and benchmark. Then, also remember this backside and foresight, ato na siyang gather or makollect na data during fieldwork or survey. Then for the HI na column, compute na nato will be computed values ni siya as well as for the elevation except sa atong known elevation, which is the elevation of benchmark A. So, sample computation. Example, complete the differential level note shown below and perform the customary arithmetic check. So, natay given nga table sa atong mo na ni atong na-gather during sa fieldwork, mo na ni nga data. So, natay formula nga HI is equals to elevation of benchmark plus backside. Also, elevation of turning points is equals to HI minus foresight. So, para makuha nga ra, elevation of benchmark 1, which is 345.971, kanya, yan sa formula, plus sa atohang backside, which is 1.256. Then, mo nang atong height of instrument sa first setup, which is equals to 347.047. So, ato na siyang i-fill in ang cell. Then, next, second formula, elevation of turning point 1 is equals to HI, which is equals to 347.047 minus foresight. Ito foresight ni 1.886. So, which is equals to elevation sa atong turning point 1. So, natay 345.161 meters above mean sea level. Muna na atong elevation of turning point 1. Next, balik ko na po na to para makompute na to ang atong elevation sa turning point 1. So, kanina po na formula. Height of instrument is equals to elevation of turning point 1 na plus backside reading, which is 1.1116. Ano siya? 1.116. Then, it will be equal sa atong second setup sa instrument, which is 346.227. 346.227 meaning 346.227 meters ang atong elevation sa ato line of sight. Then, nga rin na punta, elevation sa turning point 2 na, turning point 2. So, remember, kanilang nga formula duha. Sa turning point 2, natay height of instrument which is 346.227 minus sa atong foresight na 1.527 equals sa ato elevation sa station nato sa turning point 2. It would be equal to 344.750. Then, again na po, paano po ka elevation sa turning point 2 plus backside reading sa turning point 2 is equals to HI na na po sa HI for our third setup. So, it would be equal to 345.978. Then, sa ating magkuha na po ta og elevation, elevation is equals to height of instrument na 345.978 minus ato foresight reading na 2.27246. So, equals atong elevation sa turning point 3 na 346.732. Then, ato na pong paon ang height of instrument na po sa fourth setup. Balik-balik lang siya, which is 343.732 then plus 1.189. Atong backside reading sa turning point 3. So, which is equals to 346.921. So, atin po i-fill in ani na cell. Then lastly, which is our objective na ma-determine ang elevation sa benchmark 2 na natay elevation of benchmark 2 is equals to height of instrument, which is 344.921 minus 2 minus ato foresight reading sa benchmark 2, which is equals to 2.017. Na atong elevation of benchmark 2 is equals to 342.902. So, muna ni ang atong complete na differential level notes. Then, the second question is to perform the customary arithmetic check. Sa atong arithmetic check, we have this formula, elevation sa atong known benchmark, which is 345.791 plus summation sa backside minus summation sa foresight is equals to elevation of benchmark 2. So, atong elevation of benchmark 1 kay known. So, next atong goal is to compute the summation of foresight. So, ato siya, this column, ato siya i-add. Ito na natong backside readings, which is 1.256 plus 1.116 plus 1.228 and 1.189. Equals ana, total ana is equals to 4.789 or ibutang na to plus sign since ang atong backside is often called as plus side. The next is magbuhat ka sa summation sa foresight. Summation sa foresight kanina sa na column atong i-add na. So which is 1.886 plus 1.527 plus 2.2446 plus 2.017. So, ang total ana is equals to 7.676. Then, negative sign since foresight kay minus side. So, karon known na at elevation benchmark 1 na natay summation sa backside which is 4.789 and summation sa foresight which is 7.676. So, substitute na lang nato para ma-compute nato ang atong benchmark 2, elevation of benchmark 2. So, atong goal, elevation, atong computed na elevation of benchmark 2 should be equal sa atong na-compute a while ago. So, find nato 345.789 plus 7.789, 4.789 minus 7.676 equals to 342.90, which is the same sa atong computed. Remember na ang kaning atong na-compute elevation or atong double check or na-arithmetic check kay nagkuan na siya nga correct ato computation. Pero during survey, kung namoy mga may error sa pag-read nato sa foresight, dili na siya ma-detect sa arithmetic check. Okay, proceed na pa sa second example. Second example, natay prepare and complete the differential level notes for the information shown in the accompanying illustration. So for this problem, ang gihatag sa ato is an illustration, dili ang table. Kaya ganun na, di ba? Table diretso ang gihatag. So, mag-create ka o mag-generate ka o table mismo. So, sa atong table, natay 5 columns. Ang first, kaya itong analog station, then backside, HI or height of instrument, FS or foresight, and lastly is the elevation. So, ang ating station, ito ba nga rin, kaya natay benchmark A. Benchmark A. Then, atong turning point 1. Then, turning point 2, turning point 3. And lastly, ang atong unknown na elevation sa benchmark or atong decide or target na mahibawaan na elevation is the benchmark B. Okay. So, from Atong benchmark A with a known elevation na 125.45 meters. Katandutang nato siyang rin. Then, sa atong first setup, natay atong isite ang benchmark A na naay backside reading na 0.68, meaning from the ground to this line of sight na ay 0.68 meters. So, ato siya ibutang sa backside. Then, after nato nag-sight sa backside, yung sight na putla sa atong foresight sa atong training point 1. So, ang atong foresight reading is 3.72 sa atong training point 1 sa atong butang siya nga rin. Next, move ka sa atong instrument sa second setup. Then, musight na po ka sa turning point 1 na ito tawag na backside reading, which is equals to 0.98. So, backside sa turning point 1 sa atong station na turning point 1. So, ito tanga rin, 0.98. Then, foresight sa atong turning point 2, which is equals to 3.52. Then, sa third setup, musight na pagkabalik sa turning point 2 na backside reading equals to 3.73. Then, ang foresight reading sa turning point 3 ay 1.62. Then, sa atong last setup, atong decide ang turning point 3 yan ay with backside reading equals to 3.90. Then, ang foresight reading is 0.35. Okay. Muna niyo ang atong differential level note sa atong gather na data sa during field work. So, this, makakompute na to, with this data, makakompute na to sa atong HI, height of instrument, and elevation. Okay. So, remember nga kanila nga formula ito balik-balikon. So, elevation of PMA, 125.45, then plus atong backside reading na 0.68. Backside reading sa BMA, 0.68. So, mo na itong height of instrument equals to 126.13. Okay, ato siya, fill in ang result. Then next, second formula. Elevation sa turning point 1 kay HI, which is equals to 126.13, then minus sa atong foresight. Sa foresight reading sa turning point 1, which is equals to 3.75. And ang answer ani is equals to elevation sa turning point 1, which is equals to 122.38. So, ito siya, nari na ito siya ibutang, 122.38. The next na po, magkuha na po sa height of instrument of turning point 1. Mubalik na po yung first formula, which is elevation sa turning point 1 na. Elevation sa turning point 1, which is equals to 122.38 meters, plus backside reading sa turning point 1 na 0.98. So, muna to, elevation of line of sight sa atong second setup, which is equals to 123.36. Atin ko siya ibutang na rin yung cell. Next, kari na po ka sa second formula na po. Nalatay height of instrument sa second setup minus foresight sa turning point 2, foresight, which is equals to 3.52. So, ang answer na will give us the elevation of turning point 1, which is equals to 199.84. Next, balik sa pagkaan ni elevation, which is 119 plus 84, plus backside reading sa turning point 2 na 3.73. Mo na itong height of instrument for third setup, which is equals to 123.57. Then, elevation na po sa turning point 3 na 123.57 minus sa foresight reading na 1.64 meters. So, mo natin elevation of turning point 3, which is equals to 121.93. Next, height of instrument na po for our fourth setup. Ng elevation of turning point 3 na 121.93 plus backside reading na 3.90, which is equals to 125.53. Ang last is to determine the elevation of benchmark 2. So, we'll use this second formula. Elevation sa benchmark 2 is equals to height of instrument na 125.53 minus sa atong foresight reading, which is equals to 0.35. So, that will give us the elevation of benchmark B, which is equals to 125.48. Okay, so this is our complete na level notes, differential level notes. Then, next is mag-perform ka o customary check if sakto ba itong mga computed values. Again, the formula para sa arithmetic chart is elevation of DNA plus summation of backside minus summation of foresight is equals to elevation of DNB. So, known at elevations of DNA, which is 125.45. So, we'll compute na po sa summation of backside. So, tanang backside readings na to at siya i-add, no? 0.68, then plus 0.98, plus 3.73, plus 3.90, which is equals to 9.39. Then, summation of foresight readings na to, kanina column, at ito siya i-add tanan, which is 3.75 plus 3.52 plus 1.68 and plus 0.35, which is equals to 9.36. And kanya itong mga compute na values as well as the elevation sa DNA, benchmark A, at lang siya i-substitute ani nga formula. So, elevation of DMD is equals to 125.45 plus summation sa backside na 9.29 minus summation sa foresight na 9.26 equals to 125.48. So, same siya sa atong computed value sa BMD. So, with this, naka-kwanta nga correct ang atong mga na-compute na height of instrument as well as the elevation of the stations. Next, mga atong sample computation for differential leveling. So, next is double-radded leveling. It's a method of determining differences in elevation between points by employing two level routes simultaneously. So, same lang siya sa leveling, sa differential leveling, is just that double-radded. It means duha ang atong rad. Pero, i-take na to aning backside and foresight na to, independent na iya route. So, for this one, natay first route na ay di pa nga na nato mga H or high ng kaning route. Then, for sa atong second route, ang BMA, ari na punta sa nay mga L na route mo nito second route. Anang double-radded leveling. So, sa atong double-radded leveling, natay ani nga double-radded leveling notes. So, for instead na tig-isa lang, duha na ato sa atong mga turning point 1. So, for this one, DNA na naay elevation of 228.372. So, kanya siya, 2.8372. Then, sa atong backside reading, kung ang backside reading nato for DNA, for two level routes, same lang siya, which is 1.76. Then, ang atong foresight reading, duha na, natay foresight reading sa turning point 1L na 3.488. Then, foresight reading para sa TP8, TP1H na 2.136. 1.36. Then, after ana, at ibalhin ang atong instrument na rin sa set up. Then, murid na po sa turning point 1, which is the backside reading sa atong turning point 1H na 2.732. So, kani. Then, ang atong backside reading for TP1L na 3.079. Ano siya? So, balik-balik lang na siya until mahuman na to ang makaabot na sa benchmark 2. So, ang atong foresight reading for the fourth setup, foresight reading padung sa BM2 ay 2.809. So, sa double-radded leveling, ang atong backside reading sa benchmark 1, which is the known elevation, kay same lang. Then, ang atong foresight reading sa unknown elevation kay same result. Okay? Next. Then, to compute din aning double-radded leveling, same lang gihapon atong formula. We have the elevation plus backside is equals to HI, ang height of instrument. Then from HI minus foresight, that will give us the elevation sa atong turning point. No, naghapon, same concept lang. It's just that naduha ang atong mga turning points in the same station. Next is three-wire leveling. It's a method of determining differences in elevation wherein three horizontal hairs are read and recorded rather than a single horizontal hair. So, sa atong differential leveling, ang atong basahon ana is the horizontal crosshair. Diba? Imagine nga mo na ni ang imuhang sa katungana sa level ring or sa imong eyepiece. Makita ka o 3 ka horizontal line. For differential leveling and double-radded leveling, ang horizontal crosshair lang ato basahon. But in three-wire leveling, ato basahon ang upper stadia hair or upper crosshair, then ato sa basahon ang ato po take note ang sa lower stadia hair or lower crosshair. Like for example, kani excite nimo sa imong eyepiece, kani ang makita nimo sa imong graduated rod. So, ato siya i-record ang upper stadia hair, which is equals to 15, no? 15. Then, sa atong horizontal crosshair, nakatay 14.2. 14.2. And also, lastly, ato po i-record ang lower stadia hair, which is 13.4. Then, to compute sa three-wire leveling, mo na ni, ato in setup, kani ato terrain, then kani ato instrument tripod, this triangle, then kani ato assuming na this is the automatic level. In excite na ito nga ring, you can see 3 stadia hair. So, we have this A stadia hair reading sa upper crosshair, which is from the terrain to the upper stadia hair reading, ato siya designate as A. Then, sa ang katong horizontal crosshair, which is C, and ang sa lower stadia hair, kay D. First, ato, antay, the mean of three readings. To compute that, we'll just add the A, upper stadya hair, lower stadya hair, and horizontal crosshair at paon ng iyahang average. A plus B plus C divided by 3. The next is the stadya intercept. To compute sa stadya intercept na to, which is stadya intercept or the difference between the upper stadya hair reading and the lower stadya hair reading. So, minsan itong nabasa sa A minus B. Ano ito? Formula sa stadya intercept. S is equals to A minus B. So, kani ang atong stadya hair. Next is the horizontal distance from the level to the rod. So, ang atong horizontal distance from atong setup sa instrument to our station, mo na ang HD, horizontal distance. So, ato formula, HD is equals to KS plus C, and K is equals to stadya interval factor, and C is equals to instrument constant. Usually, given na siya, K plus K and S, K and C. Then, ang S, which is the stadya intercept, na makompute na ito ganina. Makompute using the formula nga A minus B. Then, to determine the elevation of the unknown station, so for this case, for this type illustration, na at BM2 na unknown, we have the height of instrument minus M, which is ang M kay mean of the three hair readings. Okay. So, sa atong little notes, natay ani kanang stations, then sa atong backside natay hair readings, which is ang atong A, the upper crosshair reading, then ang C sa katong horizontal crosshair, and B sa atong lower stadya hair reading. Then magpantag column na mean reading, then S, which is the stadya intercept, then HI, height of instrument or elevation sa atong line of sight. Then next, for the foresight, magpuan na po ta og hair readings na nagyapon ko upper stadya hair reading, horizontal stadya hair readings, and the lower stadya hair readings. Then mean readings niya, then S, which is the stadya intercept, and lastly is the elevation. So sample problem. Complete the differential level note shown below and perform the customary arithmetic check. So, natay elevation sa BM1, which is 444.245. So, first, atong buhaton is to calculate the mean hair readings. So, kani, for M, mean hair readings. Remember, na atong formula sa mean hair readings kay average of the three hair readings na to, which is A plus B plus C divided by 3. So, first, ato sang i-compute ni nga sa backside. So, for BM1, 1.152 plus 0.935 plus 0.718 is equals to 0.935. So, mention that. Next, for turning point 1, which is 2.784 plus 2.420 plus 2.057. And paano natin yung average sa 3 hair reading, which is equals to 2.420. So, ano po siya. The same sa adding other turning points. So, turning point 2, 1.713 plus 1.440 plus 1.166 divided by 3, which is equals to 1.440. Turning point 3 na 2.591 plus 2.904 plus 1.599 divided by 3 is equals to 2.440. 0.095. Lastly, sa turning point 4, summation sa 3 readings na 0.913 plus 0.730 plus 0.547. Then, kuha natin yung average which is equals to 0.30. So, nakuha na natin yung mean readings on the backside. So, next, paano po nato ang atong foresight mean readings on the foresight. Same formula gihapon, same na gihapon ang perform. So, for the turning point 1, which is 1.117 plus 0.8999 plus 0.682 divided by 3, which will give us 0.899. Okay. Next, same na gihapon, A plus B plus C. So, turning point 2, 1.900 plus 1.537 plus 1.172, then divided 3, which is equals to 1.536. Then turning point 3, turning point 4, and lastly is the benchmark 2. Now 1.593 plus 1.410 plus 1.227 divided by 3, ano siya, 1.410. Okay. Next, mag-compute ka sa atong stadya intercept, kaning S. Sa atong formula, we have formula sa stadya intercept which is equals to upper crosshair reading na A minus sa lower crosshair reading, which is B. So, F is equals to A plus B. So, same gihapon, inahan nato ang atong backside. So, for BM1, natay upper crosshair reading na 1.152, which is A, minus sa B natin ang reading, which is 0.718. So, BM1, 1.152 minus 0.718 equals 0.434. Then sa PP1 at 2.784 minus 2.057 equals 0.727. Then same kagapon sa other na stations. So PP2, which is equals to 1.713 minus 1.166. So we have equals to 0.547. Then sa PP3, at ibigay ang 2.519 minus 1.5999, which is equals to 0.992. Then same sa PP4, which is equals to 0.366. And kung man nato sa backside, foresight na salita, we'll compute po stadya intercept sa foresight na pod. Then, same logic nagyapon sa pag-compute sa backside. So, we have for stadya intercept sa PP1 na 1.117, then minus 0.682, which is equals to 0.435. Siya. The next, same logic lang sa PP2, PP3, PP4, and PP5. Ay, for lastly sa benchmark 2. Minus niya, minus. The next is to compute the HI and elevation. So remember, sa atong pag-compute sa elevation sa differential leveling, sa HI, we have elevation sa BM, sa known elevation, which is BM1 or BMA, then plus sa atong backside readings. But sa atong PY leveling, we have 3 readings man. So, in this case, atong gamiton ang atong mean reading. Kaning siya nga column. mean readings sa atong backside as well as mean readings sa atong foresight. Then, sa elevation, to compute the elevation sa TP1 sa atong mga turning points as well as sa atong unknown elevation na benchmark, we have this height of instrument na ma-compute nato using the first formula minus sa mean readings na sa foresight. Okay, so sample computation. For HI, which is first is the elevation of the known benchmark. 444 minus 242 plus mean reading sa backside. Mean reading sa backside. Ang mean reading sa backside nato for benchmark 1 is equals to 0.935, which is equals to 445.197. Ini siya, ano siya butang cell. Next is the elevation of trailing point 1 by HI, height of instrument, at ang computed height of instrument na 445 minus 117 minus mean reading sa ato foresight. Ang foresight na rin sa trailing point 1, mean readings nato is 0.899, which is equals to 444.29278. So, kami na so, same concept lang gihapon to other stations para makuha ang atong height of instrument and elevation. Okay. Then, muna ni ang atong complete na three-wire leveling notes. Then lastly is to perform the arithmetic check. So, for this one, we have the same formula, which is the elevation of benchmark 1 plus summation sa backside minus summation sa foresight is equals to elevation sa benchmark 2. So, dapat na itong makompute na elevation of benchmark 2 is same here, which is 445.126. Sa summation sa backside, ang atong i-add is the mean reading, computed mean readings na to sa to backside. So, summation ani na column is equals to 7.620. Then, summation sa foresight of the mean readings, which is equals to 6.736. Then, elevation to compute, at pinag-hapon siya is substitute, elevation of benchmark 2 is equal sa atong node elevation, which is 444.242 plus sa atong summation sa backside, which is 7.620 minus summation sa foresight, which is 6.3736. That will give us an answer equals to 445.121, which is the same sa atong computed na sa atong differential sa three-wire level notes na so is equals to 445.126. So with this, safe to assume na ang atong computed values for the mean readings, height of intercept, height of elevation, height of instrument, and the elevation ay correct. Okay, that would be all for today's discussion.